This is a delete node problem. Okay. Uh, so what we need to do is that it is not a normal linked list problem. So what we do in a linked list is that we connect different nodes like 4, 5, 1, 9. This is an example. So we connect different nodes. While deleting one node, what we do is that we traverse our temporary variable from the head node toward the node we need to delete. So we compare each of the values and then we delete that node, but the value matches. Okay. But here in this problem, the delete node problem, we are not given where the head node is. Okay. But so let's see, there's a way we can delete it. I will give this code in the description so that you can do it and you should try it yourself. I will explain this code to you. So let's start. First, I will tell you how do we delete the nodes in a normal linked list. So what is a linked list? Let A, B, C, D, and E be 5 nodes. Each of these nodes are referring to the next node by an arrow or a pointer. Okay. Each of these pointers containing the address of this node. Now, for example, if you want to delete this one, for example, okay, let's see. So if you want to delete this one, and this is the head, in normal linked list, we will be taking a temporary variable and assigning it to head. Okay, temp equals to head. And then we will be increasing it one by one. For example, temp equals to temp next. So in this way, we can move forward until we will take if temp data or value is the equivalent to the given value. Okay, so equivalent to the given value or maybe the given data or whatever, or maybe the given node, maybe it's a node, just in case, node value. Okay. So this is a normal scenario. Now what we have to do in this scenario, we are not given the we are not given the head. So we don't know if there's a where the head is starting. We just know that there is a head, and then there are many nodes, there are several nodes. Okay. And one sudden node is pointing toward our node. Okay, our node. This is our node. One sudden pointer is pointing to. We have no clue where this pointer is. We do not know how to start locating it. So the main problem begins is that our node refers to the next node. Here C, D, whatever it is going on here. So we need to delete this one. So how do we do that? We have to create a scenario if this is our last node. But in this question, it is clearly mentioned that the node will never be the last node. Okay, if you read it, you will get it. All the values in the linked list are, it is guaranteed that the given node is not the last node in the linked list. So it is guaranteed. That's why I have not created any if statement. But you have to check. You have to check if this is the last node or not. How do you check that? If the pointer is pointing toward null, if null, then you have to delete this one and you have to turn this node into null. Okay, you have to turn this node into null. Else, we will doing it in the regular manner. So what is the regular manner? There are two methods. Okay, one is the pointer method. It is a difficult one. Pointer method is a difficult one. The second one is a swap method. So we will be swapping this with this. How do you do that? We do not even need to swap two. Okay, you can just swap this one and then delete it. But you don't have to do it. So how do you do that? We first take a temporary variable, okay, temp, and assign value of c. Temp value equals to c. Okay, and then we assign our nodes value. Just ignore my handwriting. So you can understand it. That's it. Our node value with the temp value, and then we can free this one. Okay, and about this pointers. Right? Sorry, I forgot to mention about these pointers. I'll just help you do that. So if our node having the value of c, we also need to have the temp pointer, temp next equals to c next. Okay, so how do you get to c? Get to c, we have to go to this our node. Okay, and then we can go to c. We have to do that, and then we can transfer this value to our node next, should be pointing toward this. So this here is no more. Okay, it is now pointing toward this. Done. Now we can free this cell, and our node value is already changed. And this is how we can do it. So we are deleting the next node, deleting the next node. You see, that's how it works. We are deleting this one. This one stays, and the value changes. That's it. That's the method. So this is the given code. So for example, we are taking here the temp. Okay. For example, we'll go with this. So this is the temp. This is the given node, and we are taking temp, and we are assigning node next, or rather, this is the given node. So we are assigning the value 9 for this node value, 9 node value to our temporary variable. So next, what will be node value equals to temp. That means we are changing the node value with the temps value. What is the temp value? It's node. We know that because we have assigned this, we have assigned the temp with node next, you see. So that node value is now temp value. So here 1 have changed to 9. Node next means it is pointing toward 9. Is now equals to temp next. What is temp next pointing to? 9 is pointing to something, right? There is a list ahead. It is not the last one. So there is a list ahead. Maybe there's a null. If it is the last node, there's a null. And if it is not a last node, it is pointing to something else. For example, 5 here pointing to 1. 1 is pointing to something else, right? Similar. 1 is being deleted and 9 is pointing to something else. So we have copied that temp next into node next. And then we have created. So this here is now also not considered inside the linked list, and the temporary variable is free, so the space is no more consumed. That's it. It's an easy example. It's a super easy question, and it was. And there's another method. I will not explain that method right now because it is difficult to execute with C. So thank you guys for watching, and don't forget to subscribe my channel.